Alright, the area that is shaded represents 20% of the circle, and it has D degrees. How many degrees are in a circle?
360.
360, right. So if this is 20%, what could I divide that by?
5.
36 divided by 5 comes out to be what?
7.
72. Comes out to be 72. So if you have 72, if that's 72 degrees, it wants to know what its measure is in radians. Do you remember radians from Algebra 3? Alright, so if I want to convert 72 degrees into radians, I have to multiply by pi over 180. And when I do that, I get 72 pi over 180. Now, of course, you're going to have to reduce that. 36 will go into 72 twice, and 36 goes into 180 5 times. So 2 pi over 5, answer should be B.
Find the radius.
Okay, in the following figure, the area of the large square is 81. What is the area of the shaded square? So I always try to attack these from the point of view like I'm the high school student taking the ACT test. So that makes more sense when I explain it to you. Sometimes it doesn't work out, and sometimes I pick the more difficult way, but here's what I see when I first look at this. If the area is 81 for the entire square, then what we want to do is add this up. 2x and x. We know it's a square because it was given to us that it's a square. We don't have to even look at the sides for that.
3x.
So you have 3x for a side, and if I want the area, what do I do to a side of a square?
Find the other side.
Yeah, we'll just square it, because it'll be the same.
Is it a square?
Yeah, this is a square.
See, now the sides look longer. See what I'm talking about?
Actually, it kind of does. But if they tell you it's a square, then you have to go with that, even if the figure looks like it's not.
Oh.
So 3x quantity squared is going to be equal to 81. What's the quantity squared of 3x?
Would be 9x squared.
9x squared equals 81. So x squared would be 81 divided by 9, which is going to be 9. And a square root of both sides?
X equals
3. X equals 3, yes. So we can go back in and substitute, just for looking at it. We have a 3 there and a 6 there. 3 there and 6 there. This will be a 6. This is a 3, and so on. All of these pieces here are the same. So what I have to do is find one side of that inner square. And then when I get that, I can square that and get the area. What kind of angle is this?
Right angle.
Right angle. So what can we use to find the missing side?
Pythagorean theorem.
The Pythagorean theorem.
Oh my God, I was going to say cosine. I feel dumb.
So we're going to use Pythagorean theorem. So it's going to be
3 squared.
x squared plus the quantity squared of 2x, and then that's going to equal the missing side. We'll just call that m squared. It helps if I put the square on the m for the Pythagorean theorem. Yeah, that helps. So it's x squared plus 4x squared equals m squared. So 5x squared will indeed equal m squared.
It's going to be the square root of 45. Okay.
Well, here's what we can do next. We're going to have, if we solve for, we're solving for this, remember that. We're solving for that. So in terms of that, we'll have square root of 5x equals m. So if that's the case, then what you can do is you can insert the 3 that we had for x before, but if one side is going to be this, if this is one side, m is one side, then what is going to be the area of the whole side? What do I have to do to m?
Square it.
You'd have to square it. So you would come up with this, and if you squared that,
It's going to take away the square symbol.
yeah, if you squared that, it's going to take away the square symbol. We'll make this a. So that's going to be 5x. And then you come up with what?
Equals A.
Equals a.
So it's that 5x is going to translate into 45, so A equals 45.
Yeah, but is that one of our choices?
Yes.
It is?
Yeah, that's the first one.
Oh, I didn't even see that. Huh. Yeah, so the answer is F. I just had the screen up too far. I couldn't even see it.
I picked that.
I was looking down through there and looking at square root of 45, and the F was above the screen, and I thought, well, why is there no 45 in the choices? So there it is. This one, you have to cross multiply, so you get this. A plus B, and then A minus B. And then you'll get 10 times the quantity of A. I need to make that uppercase. Be consistent all the way through. 10 times the quantity A minus 0.1 B squared. Alright, so this, if you do that, that's a difference of 2 squares. So you can just write it like this. When you multiply it out, that's what you'll get. And when you do this over here on this side, you'll get 10A. And 10 times 0.1 is just 1. So you have a B squared. Look how convenient this is. You got the same thing on both sides, they're gone. So A squared equals 10A. I would have to,
Divide by A.
you could divide A out of both sides, yeah.
And then it would be A equals 10.
Yeah, that's it. A equals 10. J.
See,
For 48 on the xy plane, what is the area of a circle with this equation? Well, you have to remember that the equation goes like this: x minus h, and that's the quantity squared, plus the y minus k, then you have the quantity squared, and that's set equal to r squared. So what's the radius? If r squared goes here and r is the radius,
R is 7.
r is 7. R is 7 because square root this to get 7, and the area of a circle is pi r squared. So it is 49 pi. J. For number 49, you have to remember that secant x is equivalent to 1 over cosine x. So if it's equivalent to 1 over cosine, how do you reverse two letters that are that one letter apart? Oh well, I'm not even going to delete that one. Then you can say that sine x, secant x, is going to be equal to the following. If you multiply this against this, the sine ends up being on top. Like that. So after you substitute that in. And now this here, you have to remember that this is an identity. That equals just one of your trigonometric functions.
And that's going to be tangent.
And that's going to be tangent x. So the answer is A.
What the heck?
So on 55, if A over C minus A over B equals B minus C over A, with A greater than 0 and B greater than 0, as well as C greater than 0, what is the value of A in terms of B and C? So you have to start by multiplying all three terms by a common denominator of A, B, C to get rid of the fractions. So notice you have a C, B, and A. Get rid of all of the fractions by getting a denominator, a common denominator. Alright, so if you need a common denominator, of ABC, multiply everything by ABC to start with. So it'll cancel out. So it's not really a common denominator. I probably misspoke. So if I multiply this, ABC, by A over C, and then subtract ABC times A over B, and set that equal to ABC times B minus C over A. I've interchanged capital and lowercase letters. That's sloppy, but I'm not going to go back and change it. This should be a C right here. If I multiply through, this cancels out with this, and I'm left with A squared B. And then minus this B and this one, you're left with just A squared. And then this one and this one, you would have to multiply that out. Or we can just write it for right now. I'm going to change to uppercase. I know I'm not supposed to do that, but oh well. Alright. So now what do we have to do next?
Well, you have an A squared B minus A squared.
Oh,
Take that away.
there's one thing that I left off in this. The C. I remember I had to go back and overwrite it because it was looking ugly. Then after that it escaped. So it's really A squared C. You got a C in there.
So you're going to have, you get A squared cancel each other, it'll be B minus C.
Well, now A squares can't cancel each other. But you can factor. You have A squared B minus A squared C. How can I factor that?
A squared parentheses B minus C.
That's right. And then on this side, so now what can I cancel out of both sides?
B minus C.
Gone and gone. So A squared equals BC. And what do I need to do now? Because we're solving,
Oh, square root.
yeah, square root. We're looking for the value of A, so it's going to be the square root of BC.
And then